for any questions, whenever I ask for any questions, then I would like you all to please unmute yourselves and ask, because ये टॉपिक जैसा आप लोगों को पता है that we are now slightly moving towards advanced statistical analysis, and advanced analysis यानी इन टॉपिक्स के लिए बहुत important होता है that you all are understanding. और कोई भी इस तरीके की वर्कशॉप या ट्रेनिंग प्रोग्राम्स जो हम लोग ऑर्गेनाइज करते हैं या जिसमें हम लेक्चर डिलीवर करते हैं, उसमें हमारी ये एक्सपेक्टेशन होती है कि साइमल्टेनियसली साथ के साथ आपको कोई भी डाउट है या क्वेरीज हैं तो आप पूछें, सो दैट आगे चल के वो चीजें आपकी क्लियर होती जाएं और बढ़े ना. सो आई वुड बी रियली हैप्पी एंड आई वुड अप्रिशिएट if any doubts or any questions or concerns that you people have, you can simultaneously ask. You can write in the chat box, क्योंकि अभी मुझे इस लेक्चर के दौरान चैट्स नहीं दिख रहे हैं, इसलिए बीच बीच में I would like you all to unmute yourself and ask questions. So
Dr. Shambhi,
yes.
it's sorry for interruption. Actually, most of the participants are from South India, so I think it will be more appropriate to the communication in English only,
Okay,
because
great.
some people are writing the chat box.
Okay, great. Thank you. Thank you. So I would be restricting now to English only. So in the previous lectures, I think you all have studied about parametric tests. And today, the topic that I will be focusing on will be non-parametric tests. Now, first of all, before I start discussing about non-parametric tests, I would like to brief you all about the scenario when we actually use non-parametric tests. Now, I think you all by now must be aware that when we talk about statistical data analysis, we broadly classify it into two sections. One is the descriptive statistics and one is inferential statistics. I think this must be clear to all of you, as whenever we get any data for statistical analysis, as Dr. Yadav told that many of you are from medical background and many of you are from humanities or other backgrounds. So I'm quite sure that you people must have done statistical analysis, or you will be doing statistical analysis in future. So whenever we do any type of statistical analysis, I think it is broadly classified into two sections. One is descriptive statistics and the other is inferential statistics. Now, whenever we get any data, I think descriptive statistics is the first thing that we do to the data, right? We try to calculate its mean, median, mode, or maybe different measures of dispersion, right? And then we try to calculate measures of skewness, kurtosis, box plot, stem and leaf. ये थोड़ा बहुत, I think these things must, you people must have had some idea of these concepts also. So first thing that we do is descriptive statistics, and after that, when we have to draw the inference about the population, then we perform the second step, that is inferential statistics. When we talk about inferential statistics, we categorize it into two sections, and those two sections are parametric and non-parametric tests. So broadly, if we classify between parametric and non-parametric tests, it means that, so when do we apply parametric test? When we know about the distribution of the population from which our sample is drawn, then we apply parametric test. Now, what do I mean when I say this? Suppose if we have to like test that whether the average height of the participants who are attending this online workshop is say 155 centimeters. Matlab ye ek, I'm just trying to explain this concept with the help of an example, very simple. Suppose if I frame a height, you all know by now, I think you all know what is hypothesis. So suppose if I make a statement and I say that, so any statement which is capable of being tested is called a hypothesis. Okay. So suppose if I frame a hypothesis and I say that the average height of students or the participants who are attending this online workshop is 155 centimeters. Now I will have to test this. This is a statement about the population. Now I have to test it. How will I test it? I will test it on the basis of the sample that I have. That is the participants that I have. I will test it on the basis of that sample and then I will infer about the population. This is what is called inferential statistics. Suppose if I know about the distribution of the population, that is, if we say that the sample has been drawn from a population which is normally distributed. I'm repeating once again. Suppose if we say that the sample has been drawn from a population which is assumed to be normally distributed, then we can apply different parametric methods to test this hypothesis. Now, there are a lot of parametric methods, I think, which by now you must have studied, and maybe you will practice it. Like we study t-test. You people must have heard about t-test. You people must have heard about ANOVA, paired t-test, independent t-test. All of them come under different parametric inferential methods where we know about the distribution of the population from which our sample has been drawn. That is, we know that it is following a normal distribution. What happens if our population is not following the normal distribution? Right? What happens if the sample has been drawn from a population which does not follow normal distribution? What happens then? Then we go for non-parametric methods. Now I have been I have been teaching since more than 8 years now, and even before that it's been like around 12, 13 years since I have been doing statistical analysis. And like I have had many experiences where people come to us, definitely who are not from a statistics background, because I think nowadays everybody who I think you all have joined this workshop, and you all are from, like most of you are from non-statistics background. So I think you all must have joined this with the intention that you have to learn statistical data analysis, because now I think the world is moving towards evidence-based decision making, and I think it is very important to be aware of different statistical methods that have to be applied if you have to do good research. So I think we all do realize the importance. And many people come to me and they say that this is our data. I think Dr. Yadav would agree to what I'm saying, that they come to us and they say that this is our data, this is the variables that we have, and please apply t-test to this data. Because I think everybody knows about t-test. उनको पता है कि अगर हमको mean की testing, if we have to test for mean, then it is very safe to apply t-test. And everybody, they know about t-test. So many a times people come to us and they say that this is our data, mean की testing करनी है, we have to test for mean, and please apply t-test. They come to us and they say please apply t-test. But what happens is that in real life, in real scenario, trust me, it is very, very difficult to have a data that is normally distributed. Actually, like I have been in this business for say more than 15 years now, around 15 years. I have not come across a data which is exactly normally distributed. Dr. Yadav would agree. And there are many other statisticians, like my teachers, they also say that till now there is no data which we can say is exactly normally distributed. So to get a data which is normally distributed is not easy. In real life, in practice, we get those data sets. Mostly we come across those data sets which are non-normally distributed. So in that case, it would be wrong if you apply parametric methods. In those scenarios, it would be better. In fact, it is the only option that you go for non-parametric testing methods. Now, one more concern that many of you have is that if in our research paper t-test is not applied or ANOVA is not applied, will it be not good? Like, will we be able to do proper research? Will our paper get published in a good journal? It is important that your assumptions are fulfilled. As long as you are as long as your assumptions are being fulfilled, trust me, that is important. It is not at all important that just for the sake of applying t-test or ANOVA, you apply t-test. You have to make sure that your assumptions are being fulfilled. If it is not following normal distribution, please go for corresponding non-parametric. Trust me, your paper will be published in a good research journal. But if it is not satisfying the assumption of normality and still for the sake of applying parametric test, if you would apply, that would be wrong. So before I begin this lecture, I want to make it very clear with all of you that please make sure it is not only for parametric and non-parametric method. It is for every statistical analysis. I think you would study regression in the later lectures. You would study factor analysis. These are all advanced statistical analysis. For all these statistical analysis, it is important that the assumptions are being properly checked, properly verified, and only after that you go and apply these statistical tools. So number one, if your data or if your sample is not from a population which is normally distributed, please go ahead and apply non-parametric methods. You have a non-parametric equivalent for each parametric test. Abhi in the lecture slides, I will be taking you through it. So the plan is, as I have discussed with Dr. Yadav, the plan is that the first half of today's lecture would be focused on theory. Theory, I would not be focusing much on the formula because the software is going to do it for you, but at least you should understand the basics. So the first half of the lecture would be focused on, I would be focusing on you all so that you can understand the basics, when to apply. And in the second half, we will be doing the hands-on on SPSS, that is how to use all these things in SPSS. So number one, if it is not following, like if the sample is not from a population which is normally distributed, please go ahead for non-parametric. That is number one. Number two is, suppose if your data is not on ratio or interval scale. Now, I think by now you people must have heard about different scales. We have nominal, ordinal, ratio, and interval. Suppose if you have data sets which are on ranking, you have variable which is on rank, which is in the form of rank, that is ordinal scale. Then also we apply non-parametric methods. Then we cannot apply parametric methods. Or suppose if our data is in the form of nominal scale, then also, like mostly if it is categorical in nature, then we apply non-parametric methods. We cannot apply parametric methods, right? So these are some of the situations where we apply non-parametric methods. Now, why they are called non-parametric? The reason why they are called non-parametric is because we do not know about the parameters. What does parameter mean? Parameter means that we don't know about the distribution from which the sample has been drawn. We don't know about the distribution of the population from which the sample has been drawn. If we don't know about the distribution, we would definitely not be knowing about the parameters. So in that case, so isko hum dusre words mein, in other words, we can say that if the population is not following a normal distribution, or if the if sample is drawn from a population which is not normally distributed, in that case we go for non-parametric methods. Okay, this is one condition, and the other condition is that if your are in nominal or ordinal scale, then also non-parametric methods. They are also called distribution free. So, as the name suggests, that we don't know about the distribution from which the population has been drawn. That is why non-parametric methods are also known as distribution free methods. One more comparison, if I can draw between the two, parametric and non-parametric methods. I think yesterday you studied about parametric methods. So definitely parametric testing is more powerful. Now, what do I mean when I say more powerful? What happens is that when you apply certain tests after checking various assumptions, and when you are sure that these assumptions are fulfilled, I mean, when there are assumptions which are being checked, and only after you have checked for those assumptions, only after that you apply a test, it is more generalizable. You can generalize it for a larger population. That is why it is said that parametric methods or parametric tests are more powerful, because they are applied only after testing series of assumptions. Whereas in case of non-parametric methods, since we do not test for lot of assumptions, since we do not check for many assumptions, that is why they are less powerful, but they are widely applicable. जैसा मैंने पहले भी बोला, like just I said that in real life there are situations where we do not get data which is normally distributed. It is very difficult to get those data sets which are normally distributed. In practice, in real life, we generally get those data sets which are non-normally distributed. So, having said that, non-parametric tests are widely applicable, because largely we get data which is not normally distributed. Okay. Now, this is one of the examples that is written here in the slide, where we can apply non-parametric. In every situation where you could have applied parametric, you can apply non-parametric also. Like you can see the first one. While testing one training method, say A, for testing whether the average score of trainees is equal to a predefined score. जैसे हम one sample t test लगाते हैं, I think you all must have studied one sample t test, where just now I gave example also. In one sample t test, what do? We check that whether the average height of all the participants who are attending this workshop is 155 centimeters. So what I am doing, I am testing the average score, that whether it is equal to some hypothetical value or not, that is to a predefined value or not. The same thing if it is not following a normal distribution, or if we do not assume the normality, in that case we can apply non-parametric also. So this is one situation where we can apply non-parametric. Another situation where we can apply non-parametric is that when, suppose there are two training methods which are going on, and you have to see that which one is superior to the other. This could be an equivalent of the independent t-test जो हमने पढ़ा था. So in the later slides, I would tell you that which non-parametric is equivalent to which particular parametric procedure. Okay. So there are a lot of cases where we can apply different non-parametric methods. So these are some of the non-parametric tests which are generally applied. I would be explaining them in detail also, but this slide just shows a brief about these tests. So the first one is one sample sign or one sample Wilcoxon. this is equivalent to one sample t-test. Here what we check? Here we test that whether the average value is equal to one single hypothetical value. So equivalent to one sample t-test, you can apply one sample sign or one sample Wilcoxon test. Then the next one is two sample test. This is very similar to independent sample. Like suppose I have to test that whether the average height of males is equal to the average height of female. So there are two independent samples, right? Suppose if I have to see that whether the participants of North India, whether their height is equal to the participants of South India, just as an example, I am telling. Suppose if I have to see that whether undergraduate students have, say, average height is equal to the postgraduate students, like this. So when you have two independent samples, then you can apply any of these tests. You can apply Fisher-Irwin test. You can apply two sample sign test. So in the later slides, I will also show you that how these tests are applied in SPSS. We'll do the hands-on and then you would understand. So two sample sign test is an equivalent to independent t-test. Or you can apply rank sum test. It's called Wilcoxon rank sum test, or it is also called Mann-Whitney U test. All of these are equivalent to two independent samples. Okay. Then there are a lot of correlations which are available, which are for non-parametric data. I think you all know, maybe you all must have studied about correlation. Very brief, if I would explain, then correlation means that whether there is some sort of relationship between two variables, and if both the variables are normally distributed and continuous in nature, then we apply Pearson correlation. However, if the variables are in the form of ranking, then we apply Spearman rank correlation, or we apply Kendall's coefficient of concordance. So all these are non-parametric correlations. So this is also equivalent to Pearson correlation. Then suppose if we have like more than two groups. So here we can say that Kruskal-Wallis is an equivalent to ANOVA, one-way ANOVA. What happens in ANOVA? We have to check the means for more than two groups, right? We have more than two independent groups, and we have to see, we have to test that whether the mean is equal or not. So suppose if we have to test for the means for more than two groups, then we apply Kruskal-Wallis, which is an equivalent of one-way ANOVA. Then the next one is called chi-square test. Now, chi-square is used for categorical data, and chi-square actually is one test which is used in both forms. It is used as parametric also, and it is used as non-parametric also. When we test for equality of variance, then it works as a parametric. But here, since my lecture is mainly focused on non-parametric, so the non-parametric usage or applications of chi-square is one when we have to check for independence or association. That is, suppose if I have to test that whether smoking is associated to lung cancer, whether smoking is associated to gender, whether smoking is associated to alcohol consumption, or any like any two categorical variables. So generally in medical data, I would say that chi-square is one test which is highly used. And I think like since we have a lot of doctors here, they would definitely agree that I think hardly there is any medical thesis that's actually complete without applying chi-square test. So very, very important, and not only for medical, but I think for humanities, social sciences, like even in sciences, because every time we cannot deal with continuous variables. We do have variables which are categorical, and just as I said in the beginning, that when your data is in nominal or ordinal form, if your variable or data set is not in like continuous form, then we do go for chi-square test, or for that matter, we do go for non-parametric methods. So chi-square is one such test which is applied when we have to check for association between two variables. Okay. Then there is another test which is called run test for randomness. Now, this is again a non-parametric test. I would see if there is time, I would tell you that how can we apply run test for randomness using SPSS. This is basically used to test if your sample is random or not. Actually, what happens is that there are a lot of statistical methods and techniques which are only applied if your sample is random. So it is very important that your sample should be random. And in order to test that whether your sample is random or not, we can apply run test for randomness. So this checks that whether your sample is random or not. So these are brief about some of the non-parametric tests. Okay. Now, as I said that they are not as powerful or as sharp as compared to parametric, but they are widely applicable. So in real life, I think non-parametric tests are applied much more as compared to parametric. Okay. So before like wasting much time, let us start with the first test, which I said, that is one sample sign test. Now, I would not be discussing the formulas in detail, but one thing that I would like to tell you all that is very important in case of. So, do we have any doubts till now? Any questions, anybody?
No, ma'am. Very clear, ma'am.
No,
Okay.
ma'am.
Ma'am, I have a
I hope
question,
it is
ma'am.
clear
Quick
to all.
question.
No, ma'am.
I have a question, ma'am. Can I ask?
Please go ahead.
मैम आपने बोला था कि कैटेगोरिकल या सॉरी नॉमिनल या
हाँ,
ऑर्डिनल वेरिएबल हो तब भी हम लोग नॉन पैरामेट्रिक यूज करेंगे राइट
हाँ, yeah, right.
ओके मैम ओके मैम दैट्स ऑल
Yeah. So what happens is non-parametric is applied in two situations. Number one, when you have a continuous data, that is ratio or interval, but it is not following normal distribution. That is one application. Second, when you have a categorical data, जैसे chi square लगा सकते हैं और भी ऐसे नॉन पैरामेट्रिक मेथड्स हैं. दोनों सिचुएशंस में वी कैन गो इन फॉर वेरियस टाइप्स ऑफ नॉन पैरामेट्रिक टेस्ट.
ओके मैम थैंक यू मैम
Okay. So, yes, I think if there are no more questions, we can continue.
Madam, what is the equivalent for paired t-test, madam, in non-parametric?
In non-parametric, the equivalent to paired t-test is called Wilcoxon signed rank test.
And
Abhi
independent
we'll
and
study
for
that.
independent t-test, it is Mann-Whitney. Is it so, madam?
For independent, it is Mann-Whitney U-test.
Okay, fine. Thank you.
Mann-Whitney U-test is also called Wilcoxon rank sum test. So sometimes people, they get confused that both the tests are called Wilcoxon, but Mann-Whitney is also called Wilcoxon rank sum test, and it is equivalent to independent, while for paired, the equivalent is known as Wilcoxon signed rank test.
Ma'am,
Okay, it is Wilcoxon sign rank. Okay, madam.
Yes.
Thank you.
ma'am,
Hello.
Yes, yes.
I have a question. What is the randomness of the data?
So randomness means that the sample is random. The sample is being collected by some law of chance. It is not a non-probability sample.
Okay, ma'am. Thank you.
So
Hello.
whenever we go in for sampling, there are broadly we can classify sampling as probability and non-probability sample. Probability sampling or random sampling means that you collect your sample by some law of chance. That is, either it is simple random sampling or there are like different types of sampling techniques, but broadly we can say that it is random. There is no your own personal choice or your convenience, your judgment. So it is not a non-probability sample, it's a random sample, which means that you are sure that it will be a true representative of your population. While in case of non-probability sample, or if your sample is non-random, at times it comes out that it is not a true representative of the population. I'll give you a very quick example of this to understand. Very recently, we all saw the elections, the Lok Sabha elections, and in those elections, we did see the exit poll. The results of the exit poll were completely different from what the actual results were. One of the major reasons why this happened is because the sample was not random. The sample was not, the sample that was used for the exit poll was not the true representative of the population. So this is what random sample means.
Thank you, ma'am.
Clear?
Thank you,
Ma'am,
ma'am.
Hello, ma'am.
Good.
Yes.
what is the
Is it mandatory to check the randomness first before going to the testing and
Actually,
the normality?
what happens is that generally, whenever we collect data, then in the methodology section, we mention that we have gone in for random sampling, right? And
Huh.
most of the people, they do go for random sampling. If you are going in for random sampling, it's not necessary to check for randomness. But if you
Okay.
are not going in for random sampling, then you should definitely check. I mean, it's an ideal practice if you check in for randomness, but
Yeah.
people, they don't, but it would be ideal if you do that.
Yeah. Okay. And what about the normality? Is it again mandatory to check the normality of the data and then go
Yes,
for the non-parametric
yes,
or parametric?
yes, absolutely.
Huh.
You can only decide that you will go for parametric or non-parametric if you check for normality.
Okay.
It is definitely the most important and the first step which
Hmm.
we do when we apply parametric or non. I will, when we do it on SPSS just now, I will show it to you all that how to check for normality. I'm not sure if you have done that before or not, but I will show it to you once again how to do that on SPSS. It is definitely the most important and the first step which you will do in order to decide that whether you have to go in for parametric or non-parametric.
Madam, I have a doubt here. What is the
Uh,
equivalent for correlation coefficient, madam? You said Spearman coefficient and one more name you have given.
Kendall, Kendall. Both of them are used for ranking data or for data which is not following normal distributions.
Fine, madam. Thank you.
Yeah, so we can go in for Spearman or Kendall.
Ma'am, like we see a lot of randomized controlled trial, but so far we have not come across this term run test. So as you have just mentioned that it is needed in case where we have not done the randomization,
Yeah,
just
right.
to okay. So in study it is necessary to do this test so as to increase the validity of the study.
Now, what happens with an RCT is that RCT by nature is random. I mean, you cannot allocate if you are not following a proper randomization rule, right?
Yes, ma'am.
Either you go in for a simple randomization, or you go in for a block randomization, or you go in for cluster. I mean, there are a lot of methods, you must be aware of that. So
Yes, ma'am.
RCT by fundamental nature is randomized. So I don't think it's important to check for it's important to apply run test, because I mean, you cannot go ahead in an RCT without going in for randomization. So there is no point to additionally apply run test there, and that's why maybe none of them do it, because
Yes.
by fundamental nature you have to go in for randomization if you are going in for a randomized control trial.
Okay, ma'am. Then in which kind of study we do this test so as to
Like
check?
suppose if I am conducting a normal, like I am doing a normal study, okay, and
Yes.
if I say that, like I have to check that whether the height of the participants who are attending this is 155, just as an example, right? Now, suppose if, like, for me, it is convenient to take people who are from Lucknow or who are from North India. Suppose if I take that kind of a sample and I check, that would be wrong, because I am taking a sample according to my convenience, but it does not, like, it is not a random sample, because we do have participants from south, we have participants from east, like from different corners of the country. So in
Oh,
that case, if I follow my own convenience, it would result in a sample that would be non-random. And anyways, if your sample is non-random, your results would not be correct.
Okay, ma'am.
Okay.
Okay, ma'am. Again. Thank you, ma'am.
Great. So I think I should now continue, because we have no further questions. I'm so happy that there are a lot of questions that you people are asking, because in an online workshop, if there are so many questions, then like the person who is taking the lecture feels so elated that people are actually listening to the lecture. So I'm so satisfied that we have an audience who is listening to the lecture. Okay. So, yeah, so one sample sign test. Now, this is an equivalent to one sample t-test. Now, what happens in one sample t-test? We check that whether the mean is equal to a hypothetical mean. I think आप लोगों को, you people must be aware of the null hypothesis that we check for one sample t-test. It is that mu is equal to mu naught, right? What is mu? It is the mean. And what is mu naught? It is the hypothetical mean. That is the mean that we assume. So what happens in one sample t-test? We check that whether the mean is equal to a hypothetical mean. In case of non-parametric, what we do? We check that whether median is equal to a hypothetical median. Now, why did I say this term median? अब से लेकर के और जितने भी नॉन पैरामेट्रिक मेथड्स हम पढ़ेंगे, लाइक different non-parametric tests which we will study in the future, for all these non-parametric methods, we would be using the term median and not mean. One reason why we check for median is that, as I said, that non-parametric methods are applied if your data is not following a normal distribution. Okay. Now, I think you all must be aware of the shape of the normal distribution, right? It is a bell-shaped symmetrical curve. I think most of you must have seen the normal probability curve. It is a bell-shaped symmetrical curve. If you draw a line at the center, you will have equal number of observations on the left and equal number of observations on the right. Okay. If your data is not following normal, then it would be a skewed distribution. Now, what does it mean when I say skewed? Skewed means there will either be a longer tail to the right or there will be a longer tail to the left. In case of a skewed distribution, median is always the appropriate measure and not mean. Okay, I'm repeating, in case of a skewed distribution, like whether it is left is skewed or right is skewed, that hardly matters. But in case of a skewed distribution, always remember that median is more appropriate as compared to mean. That is why whenever we go for non-parametric test, we always test for median. That is one reason. Okay. So now whenever I say that whether the average height is equal to some hypothetical height, here average means median. Okay, and not mean. So always remember, for all the non-parametric tests, you will always check for median and not mean. That is number one. Number two is that since we apply all these non-parametric tests on ranking data. So what ranking means, I think rank must be clear to all of you. when we rank our data. It could be from lower to highest, it could be from highest to lowest, when we have to rank our data. Yeah, when we do it on ranked data. Now, since we apply non-parametric tests on ranking data, that is why for ranks, we always calculate median and not mean. So these are some of the reasons why I will always talk about median whenever I will talk about non-parametric, and you all also, whenever you write the interpretation of non-parametric, we always write that median is not equal to the hypothetical median, okay, or the median for both the populations is not the same. We never talk about mean when we talk about non-parametric. Okay, I hope this is clear to all of you. So equivalent to one sample t-test, we have one sample sign test. So this is the test statistic for it. The value minus the expectation divided by under root of variance. Let us not go much into the detail of the formula again. This is the null hypothesis, whether median is equal to a hypothetical median, and you check it against either two-tailed alternative, or we go in for one-tailed. That is, it could either be right-tailed or it could be left-tailed. I think you all must be by now aware of what is two-tailed and what is left-tailed and what is right-tailed. Now, in the next 2 points in the test statistic, it is actually telling you that how do we calculate the uh, uh, like test statistic. It is based on the science. So we are not going into all those details now because we don't
Madam,
have
this
that much.
hypothesis is null hypothesis or the test hypothesis, madam? That H0 n equal to n0.
H0 is always called null hypothesis. Always remember, if we write 0, then it will be null.
Okay.
And also always remember that null hypothesis is a hypothesis of no difference. That is why it is called null hypothesis. No difference means that it is
Thank you, madam.
equal. It is same, right? So here the null hypothesis means that median of your population, which is like the sample median, is equal to mu naught, which is your hypothetical median. ठीक है, बस मीन की जगह यहाँ पे क्या रिप्लेस हो गया, मीडियन. So this is how we calculate the S value. It is based on signs. That is why it is called sign test. Based on sign means that if the signs are positive, then we like add a value. If it is negative, then we like there is some calculation which is based on the signs, and on the basis of the signs we calculate S, and फिर उसको formula में use करके we try to calculate the test statistics. So not going into that detail. Simple rule is that we like decide on the basis of p value. So if your p value, I think you all know what's the p value, the probability value. So if it is less than 0.05 at 5% level of significance, then we reject the null hypothesis. If it is greater, then we accept the null hypothesis. Okay. So one sample sign test equivalent to one sample t-test. Next, we go for Wilcoxon test. This is also like we can apply one sample sign test. We can also apply one sample Wilcoxon test. This is also equivalent to one sample t-test only. Same होता है ये भी. यहाँ पर भी we check that whether median is equal to hypothetical median. बिल्कुल same होता है. So you can go in for sign test. You can go for Wilcoxon test. This is how we do it, not going into the formula. Okay, now the next, I think some of one of you had even asked this question, that what is the equivalent of paired t-test. So as I said, Wilcoxon signed rank test, this is the equivalent to, it is the non-parametric equivalent to paired t-test. So when do we apply paired t-test? Like suppose if all of you all are from different streams, and suppose if before the start of this workshop Dr. Yadav plans to assess your knowledge of statistics. Okay, you are being given a questionnaire and kuch questions आपसे पूछे गए, and then your knowledge of statistics was assessed and you were being given some score, right? Then after this 1 week online program, again your knowledge was being assessed. This is an example of a paired sample. Paired sample means that you have paired observation on same individual. So the like it is used in case of before and after. Either it could be a diet program or it could be some type of meditation or anything. Whenever you take a sample that is at one point of time and then you do certain intervention and then again you take a repeated observation on the same set of individuals, that is called a paired sample. Okay, now if it is following normal distribution, we go and apply paired t-test, while if it is not following normal distribution, then the non-parametric equivalent of paired t-test is Wilcoxon signed rank test. Okay, now here the null hypothesis is nu1 minus nu2 is equal to 0. If you remember, in case of paired, the null hypothesis is that d is equal to 0. So here we always talk about difference. तो यहाँ पर भी वो difference ही निकाला है, लेकिन बस here they are taking the differences between the two medians rather than the two mean. Okay, so here the null hypothesis could be that the like the median of one population is equal to the median of two, ऐसे लिख सकते हैं, या फिर you can also say that both the samples are drawn from identical population. This could be the null hypothesis that both the samples are drawn from a population which is the same against the alternative that both the populations are different. Okay, so this is Wilcoxon signed rank test. Now this is how we calculate the test statistic. It is based on the ranks. You calculate the positive. Again, since like all the non-parametric tests are only based on the ranking. So here also you calculate the positive ranks, then you calculate the negative ranks. फिर दोनों में we see what is the minimum value. Then that minimum value gives you the test statistic. Then that test statistic is compared with the tabulated value. Again, if it is less than like p-value, then you reject it. Otherwise, you accept it. Okay. So paired t-test equivalent is Wilcoxon signed rank test. Next, we come to independent sample. Independent means that there are two groups which are independent from each other. Always remember one thing, that when we apply paired t-test, both the samples have to be like you should have equal number of observations. क्योंकि जैसा मैंने बताया that they are the paired samples. Paired sample means that like you will have same number before and after. But in case of independent sample, there is no such assumption. You can have different numbers. You can have different number of males and you can also have different number of females. So when we apply independent t-test, it is not necessary that you have same number of observations. Okay. So the non-parametric equivalent of independent t-test is called Mann-Whitney U-test. It is also called Wilcoxon rank sum test. Here, the null hypothesis is that both the populations are identical, or you can say that there is no difference in the average scores of both the populations, or you can say that there is no the median for one population is equal to the median of another. Like all these things could be said if we go for Mann-Whitney U-test. While in case of the alternative, you can say that there is a difference. This is also based on ranking. Here, the statistic is called U statistic since we calculate the U statistic here. That is why it is called U statistic. And that's why this test is called Mann-Whitney U-test. Here also we compare the value with the tabulated value. Now, after Mann-Whitney U test, again, one of the very important tests which we do is a non-parametric equivalent to one-way ANOVA, and this is called Kruskal-Wallis. Now, what do we do in ANOVA? In ANOVA, we test that whether the average for all the, like suppose if we have three populations. So basically, ANOVA is an extension of independent t-test. I think in one line, if I can tell this to you all, then ANOVA is an extension of independent t-test. In independent, it's actually a generalization of independent. In independent t-test, we check for the means of two groups, while in case of ANOVA, we test that whether more than when we have more than two groups and when we have to check for the equality of their mean. Suppose if they are not following a normal distribution, then what we will do, we will apply Kruskal-Wallis test. Here, again, the null hypothesis would be that whether the median of all the 3 or 4 or like n number of populations that you have, whether the median is equal or not, or you can say in other words that whether k populations are identical or whether the k populations are not identical. That would be your alternative hypothesis. Okay. So this is how we calculate the test statistic. This is again H is the test statistic. The formula how we do it. Not going into the detail of the formula again. Then the next non-parametric is called Friedman test, which is a non-parametric equivalent of two-way ANOVA or repeated measures ANOVA. Now, what repeated measures or two-way ANOVA means? Two-way ANOVA means that in one-way ANOVA, there is only one factor which we compare across the groups. Like suppose if we say that whether the average height across the three different groups is the same or not. Suppose if along with height, we also consider weight, height and weight, then we go for Friedman test, or then we go for non-parametric. Okay, or two-way ANOVA. So it means that when along with one factor, you also take into consideration like more than one factor, then we go for two-way. Or what repeated measure means? Repeated measure means that when repeated measure is basically a generalization of paired t-test, if I can say. In paired t-test, what happens is you have an observation of before and after, right? Suppose if I take repeated observations at 3 or more different time points. What do I mean when I say 3 or more different time points? Suppose if I take your height today, or maybe weight today, because height doesn't vary much. Suppose if I take your weight today and then I take your weight after a week and then I take your weight after 10 days, right? So this is a case of repeated measures ANOVA. When you go for repeated observations and they are not following normal distribution. So in that case also we apply Friedman test. I will show it to you how to do this on SPSS. I'll try to cover each and every test with an example so that it is clear to all of you that how do we do this on SPSS. I will share the data set with Dr. Yadav and he will share it with all of you. So you can do all these
Hello.
tests on SPSS also.
Hello.
Yes.
Sorry to interrupt you, ma'am.
Yes, yes,
Repeated measures ANOVA can be useful for the follow-ups for the treatments. Am I right?
absolutely, absolutely correct.
Follow-ups day 1, day after, day 2,
Yes,
day 2.
yes, absolutely.
Okay. Thank you so much.
Suppose if you have a measure and you take the observation today and then the patient comes after 1 month and then the patient comes after 2 months, so you have repeated observations, and if it is following a normal distribution you go in for repeated measures, but if it is not following normal then we go for Friedman test.
Okay. Thank you.
I think I've also given an example here at the end of this slide, if you all can see. Patient serum content monitoring before treatment, after 1 month, and after 3 months of treatment, along with COVID testing. So these any measure, if you take like if you go in for a follow-up study, you can definitely go in for repeated measures ANOVA. So this is the null hypothesis here, that median of all the groups are the same, or you can say that populations are identical, against the alternative that population is not identical or median is not same. This is how we calculate the test statistic for Friedman test. Not going into the details. Yes. The last and the most important non-parametric test, which is highly used, especially in medical sciences, is called chi-square test. Now, it is used in both ways as non-parametric. It can either be used as a goodness of fit test, or it is also used as a test of independence or association. Now, what does independence or association means? Independence or association means that if you have to test that whether like there are two categorical variables, and you have to test that whether there is some sort of association between the two categorical variables, smoking and lung cancer, smoking and obesity, smoking and heart disease, any two categorical variables. Goodness of fit means that whether your sample on which you are performing your analysis, whether it is fitting a particular distribution or not. Now, what happens is that just now I told you in the beginning of the lecture that whenever we apply parametric or non-parametric, it is important that we test that whether your sample is from a population which is normally distributed or not, right? So it is important that we test for the goodness of fit. And it is not only for normal distribution, it can be used for many distributions. In statistics, we have a lot of distributions, and I think we are not going into that technical detail right now, but we have exponential, geometric, hypergeometric, many distributions. So goodness of fit test is actually applied to check whether the sample is fulfilling the properties of a particular distribution or not. Agar aisa hai, then all the properties of that distribution could be applied on your sample also. So goodness of fit plays a very important role in statistics, and chi-square test can also be used to check for goodness of fit.
Can you explain with an example what is goodness of fit?
Yeah, so just now I had given the example. Suppose if I have to check that whether my population is like the sample that I am working on, whether that sample is from a population which is normally distributed. This is a test of goodness of fit for normal population. Whether my sample is able to properly fit with a normal distribution. So you can check it for normal.
When my sample is getting the goodness of fit, then I will apply chi-square test.
Yes.
Or
Chi-square test is applied to check the goodness of fit. But goodness of fit for what? So goodness of fit is always tested for a particular distribution. Chi-square test is a way by which you can check the goodness of fit. But goodness of fit is always checked for a particular distribution. That whether the sample, like the population from which you have taken the sample, whether that population is following a normal distribution or not. It has to be for a certain distribution only.
मैम chi-square टेस्ट जो होता है वो तो नॉन पैरामीट्रिक टेस्ट में होता है. नॉन पैरामीट्रिक टेस्ट जब हम अप्लाई करते हैं जब हमारा पॉपुलेशन नॉर्मल डिस्ट्रीब्यूशन फॉलो नहीं करता, तो
नॉन पैरामीट्रिक जी हाँ बताइए.
तो फिर हम कैसे मैम यानी फिर टेस्ट यूज करें गुडनेस ऑफ फिट के लिए?
गुडनेस ऑफ फिट के लिए हम chi-square टेस्ट यूज करते हैं. ठीक है. chi square by virtue, as I said, एक पैरामेट्रिक टेस्ट की तरह भी यूज किया जाता है, नॉन पैरामेट्रिक टेस्ट की तरह भी यूज किया जाता है। अब गुडनेस ऑफ फिट आप किसकी चेक करेंगे? आप ये देखेंगे ना कि आपका डेटा किसी डिस्ट्रीब्यूशन को फॉलो कर रहा है कि नहीं। वो कोई पैरामेट्रिक डिस्ट्रीब्यूशन भी हो सकता है, नॉन पैरामेट्रिक डिस्ट्रीब्यूशन भी हो सकता है। तो नॉर्मेलिटी के लिए भी चेक किया जा सकता है, किसी नॉन नॉर्मल मतलब किसी नॉन पैरामेट्रिक के लिए भी चेक किया जा सकता है। मतलब हमें ये देखना है कि हमारा डेटा एक पर्टिकुलर डिस्ट्रीब्यूशन को फॉलो कर रहा है कि नहीं। उसको चेक करने का जो प्रोसेस है वो काई स्क्वायर टेस्ट के द्वारा किया जाता है, जिसको एक नॉन पैरामेट्रिक टेस्ट कहा जाता है।
Hello,
Is this doubt clear?
ma'am, I have a question.
Yeah, but let me first check with the person who was asking this question. Is this doubt clear?
मैम पर्टिकुलर डिस्ट्रीब्यूशन फॉलो कर रहा है या नहीं कर रहा, उसका मतलब मैम थोड़ा समझ में नहीं आया। जैसे
अगर वो उस डिस्ट्रीब्यूशन को फॉलो कर रहा है तो उस डिस्ट्रीब्यूशन की सारी प्रॉपर्टीज ऑटोमेटिकली आपके डेटा में फॉलो हो जाती हैं। मतलब अगर हम ये मान के चलते हैं कि हमारा डेटा नॉर्मल डिस्ट्रीब्यूशन को फॉलो कर रहा है, तो नॉर्मल की जितनी प्रॉपर्टीज हैं वो हमारा डेटा सेटिस्फाई करता है, तभी तो चेक किया जाता है। ऐसे स्टैटिस्टिक्स में बहुत सारे स्टैंडर्ड डिस्ट्रीब्यूशंस हैं। जैसा मैंने पहले भी बताया कि अगर हमारा डेटा उस डिस्ट्रीब्यूशन की प्रॉपर्टी को फॉलो कर रहा है तो अपने आप उस डिस्ट्रीब्यूशन की जितने भी क्राइटेरिया हैं वो डेटा में फुलफिल हो जाएंगे। इसलिए इंपॉर्टेंट होता है गुडनेस ऑफ फिट टेस्ट करना। एक बार अगर हमको ये पता चल गया कि ये डेटा इस डिस्ट्रीब्यूशन को फॉलो कर रहा है तो ऑटोमेटिकली उसकी सारी प्रॉपर्टीज फुलफिल हो जाएंगी।
ओके, थैंक यू मैम।
Ma'am,
Yes.
that we are doing this chi-square test to test for the goodness of it. For example, like I would like to know whether my data is following the normal distribution or not. If it is following the normal distribution, and I would understand from the chi-square test that the data is normally distributed. If it is fit.
Yes, absolutely correct.
If it is not fit, then the data is not distributed.
Yes.
Okay. Then-
Ma'am, ma'am, I have a question.
Please go ahead.
Actually, you already have explained that chi-square test normally used for categorical data or
Yes.
qualitative data.
Yes.
But
One of the usage of chi-square is for categorical also. That is
yes, ma'am.
independence and association.
Yes, ma'am. Ma'am, you already have mentioned that it can be used for used to test if the data is normally distributed, or if the data is not normally distributed, we can also use chi-square test. Okay, so
Yes,
many.
That is goodness of it. Chi-square has many applications. One
Yes, ma'am.
application is goodness of it. One application is association. Yeah.
So, is there any other criteria for that thing? We can only use chi-square test because so many tests are available. For example, for normal distribution data, we already have learned that so many tests are available. So
Yes,
why?
you
Yeah.
can use many. You can use other tests also.
Yes, ma'am. Yes.
It is not necessary that you only use chi-square. Chi-square generally chi-square
Ma'am,
goodness.
can I say something?
Ma'am, can I complete myself first of all?
Yeah, please.
Yes, ma'am.
chi-square test ऐसा है कि कोई भी डेटा हम इसमें डालते हैं तो वो बता दिया कि ये डेटा जो है नॉर्मल डिस्ट्रीब्यूशन कर्व को फॉलो कर रहा है या इसमें स्क्यूनेस है।
सिर्फ नॉर्मल की गुडनेस ऑफ फिट चेक करने के लिए नहीं होता। chi-square बहुत सारे डिस्ट्रीब्यूशंस की गुडनेस ऑफ फिट यूज किया जा सकता है।
Yes, ma'am. So, ma'am, I have a question that is there any other particular criteria that we just normally use? We just only use chi-square test for that thing only.
For association, you only use chi-square test.
For association. Okay.
Yes.
Yeah. Okay. Thank you.
For independence or association, we only go for chi-square test.
Ma'am, what about correlation?
Participants, can we take the questions after completing the session, theory session? Otherwise, we will miss the hands-on. So please keep your questions posted in the chat box. So first we complete the session and we'll take the session, take the questions in the last.
All right. So going ahead with chi-square goodness of it. This is an example. This is how we calculate the test statistic, observed and expected frequencies. And then we calculate the test statistic. These are some of the examples where we can go for chi-square test of association or independence. Both the variables have to be categorical in nature. They can have two categories or they can have more than two categories. It is not necessary that your categorical variable only has two categories. The only thing that is important is that both variables should be categorical in nature. This is called a contingency table where you have rows and columns. This is made here to in order to explain you all that how we calculate the observed and expected frequencies. Expected frequencies are calculated by row total into column total upon grand total. So not going into much detail of the formula. Always remember, very important, null hypothesis for chi-square test of association. The null hypothesis is that there is no association. So between the two categorical variables or between the two attributes, the null hypothesis is that there is no association against the alternative that there is an association. So this is how we calculate the test statistic. One more test which is used along with chi-square, and that is also a non-parametric, is called Mech-Nimar test. Just now, I think it is important for you all to just note its name. Now, Mech-Nimar test is used when we take a data which is in the form of a paired and nominal data. Now, paired dichotomous, what this means? What this means that suppose if I say that whether the disease was present or absent today, and then suppose after a follow-up, like after a week's follow-up or after a month's follow-up, again you try to check that whether the disease was present or absent. So you have a dichotomous data, okay, that is present and absent, and you have it also in the form of paired because it is before and after. So when we have a paired dichotomous data, then we go for Mech-Nimar test. So it is very similar to chi-square. The only difference is that it is used when you have a paired dichotomous data. Okay. These are some of the examples where we use Mech-Nimar test. Okay, one more test which is also used is called Cochran-Q test. This Cochran-Q test is again a generalization of Mech-Nimar test. In Mech-Nimar, as I said, we have two groups before and after, and we have a dichotomous data. In case of Cochran-Q, we have three or more groups and we have a dichotomous data. So Cochran-Q is an extension of Mech-Nimar. Don't worry, at the end, and this is the run test, I think this we have already discussed, it is for randomness. So this is a summary of all the parametric and non-parametric tests which we have discussed till now. For each parametric, we have a corresponding non-parametric. So one sample, then you have two sample independent, then you have paired, then you have one-way ANOVA, Kruskal-Wallis, and lastly you have repeated measures or two-way ANOVA. Okay, so this is all about the theory.
Madam,
Very
can you
quickly,
show the examples of Mech-Nimar test?
so let me do it on SPSS and then I will discuss the examples also.
Okay.
मैम
हाँ,
मैम ये पीपीटी आप शेयर कर सकते हो मैम इस क्लास के बाद.
yes, I will share it with Dr. Yadav.
ओके, थैंक यू मैम.
Is my screen visible to
Can
all
you
of
show
you?
last slide, please?
Yes, madam.
Can you show the flow chart slides?
This one.
Yes, ma'am. Thank you, ma'am.
Shall I go ahead? Is the data set visible to all of you? Is the SPSS data set visible to all of you?
Yes.
Yes, ma'am.
So this is an SPSS data which I will be using for demonstration purpose. Now, what this data is actually about, let me tell you that. This is again a medical data that has been used here. This is a data on 35 individuals. We have their place of residence, that is rural and urban, then their gender, their age, whether they belong to the morning group or they belong to the evening group. There was like two groups where the patients were given some special intervention along with the treatment, and then their depression scores. Depression score at day 1, then after certain time point, like after a follow up, and then after third follow up. So there are 3 depression scores. Then their marks, they were given some test, and on their test the marks that they had scored finally. So then their marks and their family's monthly income. Okay, so this is on 35 individuals. I hope the data is clear to all of you. You all have an idea of the data set now?
Yes, ma'am. Yes, ma'am. Yes,
Right.
ma'am.
So
Yes, ma'am.
going ahead with the analysis. Now, since I will be doing this on SPSS, although the recordings would be shared with all of you, but I would advise you all to please either take the screenshots of the steps that I will be doing here or write it down on a paper. I think I believe in the old school and I prefer writing. And trust me, I studied SPSS way back in the year 2011 and 12. And since 12 years, I still have those notes which I made 12 years back, and I still refer to those notes. Fortunately, I was being taught by an excellent teacher, and I think whatever I know today, major credit goes to him as well. So I noted down all the steps, and I still refer to that notes. It's been more than 12 years now, but I refer to those notes. So I think I'm not sure that today in the world of taking screenshots and like recordings and all, how people do that. But I prefer keeping down, noting down, and properly preparing and making notes. I prefer that old school teaching method still. So I would advise you all, if you all are making any notes or if you all are writing them down, please write down the steps of all these tests so that whenever you practice, this data would be shared. And I'm assuming that you all will practice. So, excuse me. So, when you practice it on SPSS, make sure you are referring to those notes. Okay. Now, before we apply non-parametric test, the first thing that we do is we check for the normality, that whether your data is following a normal distribution or not. Now, I have this variable age. Okay. Now, suppose if I have to check that whether the average age is equal to 25 years. Now, 25 is my hypothetical value, जो हम कुछ भी ले सकते हैं. It depends on your past literature. It depends on it's your choice. Okay. Now, suppose if I have to test that whether the average age is equal to 25 years. First thing that I will do is I will check that whether age is normally distributed or not. How to do that? Go to analyze, go to descriptive statistics, and go to explore. In the dependent list, put age. You all can stop me at any time if you feel that I am going too fast. In the dependent list, put age. In the plots, click on normality plot with test and click on continue and click on OK. As soon as I click on OK, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. And is the screen also visible?
Yes.
Yes, ma'am.
Yeah. Okay. So as soon as I click on OK and I get an output, now this is my tests of normality. Here we have two tests. One is called Kolmogorov-Smirnov and the other is called Shapiro-Wilk. Now Shapiro-Wilk is applied for small samples and Kolmogorov-Smirnov is applied for large sample, right? Now what does small and large sample means? When your number of observations are 50 or less than 50, generally 30 liya jata hai as a small sample and large sample. 30 is the cutoff, but nowadays definitions has slightly changed, so we take it as 50. So if your sample is less than, sample size is less than 50, we go for Shapiro-Wilk test. Otherwise we go for Kolmogorov-Smirnov. So in this case we will go for Shapiro-Wilk. Okay. Now how to check that whether your data is following a normal distribution or not? We see this p value. Okay, this SIG or significance value is known as p value. Okay, now if this value is less than 0.05, then as I said, we reject the null hypothesis. Here what is the value? It is 0.000. Now always remember, all of you, 0.000 does not mean that it is exact zero. It means that it is tending to zero. Since it is a probability value, so it can neither be exactly zero or it can neither be exactly one. So 0.00 means कि वो आगे जाके किसी decimal place पर there will be some value, but it is tending to zero. Anyways, it is very less than 0.05. Since it is less than 0.05, at 5% level of significance, we reject the null hypothesis. And in case में null hypothesis क्या होती है? For Shapiro-Wilk and even for Kolmogorov-Smirnov, the null hypothesis is that data is normally distributed. Okay, since we reject it, hence we conclude that data is not normally distributed. So now we know that age is not normally distributed. Is this interpretation clear to all of you?
Yes, ma'am. Repeat this process
Yes, ma'am.
again, ma'am.
Yes,
Repeat the interpretation or how to apply the test.
How to apply
Ma'am,
the test, ma'am.
interpretation.
Repeat process, ma'am.
Right. I've got it. So I will first repeat how to apply and then I'll repeat the interpretation. Analyze, descriptive statistics, explore. In the dependent list, put age. You put that variable in the dependent list whose normality has to be checked. So in the dependent list, I have put age. Okay. Then in the plots, click on normality plots with test. And then click on continue. And click on OK. So I'm not going into all the others. I will just go into test of normality. I request you all to please mute yourself. अपने को प्लीज म्यूट रखिए आप लोग. I request you all अपने को please mute रखिए. Okay. Sorry for the interruption. Right. Now, as I said that if your sample is less than 50, we go for Shapiro-Wilks, and if it is more than 50, we go for Kolmogorov-Smirnov. So in this case, we go for Shapiro-Wilk test. The null hypothesis is that data is normally distributed. We decide that whether we have to reject or accept on the basis of significance or the p-value. Since significance is less than 0.05, we reject the null hypothesis and we conclude that data is not normally distributed.
हम अपने नल हाइपोथेसिस में जब भी कुछ हाइपोथेसिस लेते हैं तो हाइपोथेसिस ऑफ नो डिफरेंस, तो इस केस में अपने क्यों ऐसे ले रहे हैं कि
there is no difference between
नॉट नॉर्मली डिस्ट्रीब्यूटेड क्यों
हाँ
नहीं
हाँ
ले
बता रही हूँ नो डिफरेंस की लेते हैं ना, तो there is no difference between normal distribution and your data. Is it clear?
Yes, ma'am.
Yeah.
I have one more doubt. In a
Yes.
data set, we may be using like different variables. So when we will be applying different tests also in the same data set, like height, weight, age, gender, so many things we compare. So for each comparison, do we have to keep testing the normality each time we do it and then decide to go for a parametric or non-parametric test? Is it done like that?
Yes, of course, it is done like that. For each variable, you need to check for normality separately.
Okay, ma'am. Thank you.
And hello, ma'am. And if
Ma'am,
one variable is said to be parametric, matlab normally distributed, and other one is not normally distributed, other variable, and when we have to compare both, then
Actually, it depends on what test you are applying. Like, for example, if you go for independent t-test. So for independent t-test, both the variables should be normally distributed. If any one is not normal, you will not go for parametric.
okay, ma'am.
If you go for ANOVA, and if you are doing it on 3 different groups, for all the 3 groups, it should be normally distributed. Even if it is not normal for any one group, you should not apply parametric.
Okay, ma'am. Okay, thank you. Thank you, ma'am.
Ma'am,
Any
in this
other
case,
question?
ma'am, in this case, this is showing the significant. It means that data is not distributed. This is normally.
Significance is the p-value, and this significance value will be shown for every test. कल आप लोगों ने शायद पैरामेट्रिक पढ़ा होगा एंड आज हम नॉन पैरामेट्रिक पढ़ेंगे. ये p वैल्यू सब टेस्ट्स में आता है एंड इसी के बेसिस पर वी डिसाइड that whether we have to reject the null hypothesis or we have to accept the null hypothesis.
Okay. Ma'am,
So
here the question is that the data is equally normally distributed or not? It's significant.
Let me please complete. What's important for you is to know what is the null hypothesis for each test. अगर null hypothesis अच्छे से पता है आपको, तो इस SIG वैल्यू के बेसिस पर आप डिसीजन ले सकते हैं. इसका डिसीजन फिक्स होता है. If this SIG value is less than 0.05 at 5% level, you reject H0, otherwise you accept H0. What's important for you to note is what is your null hypothesis. So for tests of normality, the null hypothesis is that data is normally distributed.
Okay, so I think we can proceed because time is running fast. And,
Yes.
yeah, so we'll take the questions after completing the session.
Okay.
So I'm muting all the participants. So Dr. Shramvi, please unmute yourself.
Okay. So now we will not be taking
Yes,
any
so-
further questions. We will be
Yes, so we'll take
completing
in the
the
last.
analysis.
Take in the last.
You all can write down your questions after the end. At the end, we will be taking all the questions together. So so now since we know that age is not normally distributed, that is why we apply non-parametric equivalent, which is one sample sign test, which I already discussed with you all. Now, how to do it on SPSS? Analyze, non-parametric, and here you click on one sample. Analyze, non-parametric, click on one sample. As soon as you click here, you see a dialog box which is opened. In the dialog box, in the objectives, click on Customize Analysis. Then click on Field. Now in the field, actually what happens here, all the variables are on the right side. Now generally what happens in SPSS, the variables on which we have to work, only those variables have to be on the right, others have to be on the left. Here all the variables are on the right. So what we have to do? We have to put all these variables which are on the right back on here, and only the variable on which we have to do the analysis, only that variable should be in the test field. So हमारी null hypothesis क्या है? That whether the average age is equal to 25. And since we know it's non-parametric, so we will apply one sample non-parametric. So in the test field, we will only use age. Okay. So what you do? You have to put all these variables back. Now, one way is one by one you can put them back. Other is that you select all of them using shift key, shift and downwards arrow. Select all of them, put them on the left, again select age and put it on the right. Now I will only be working on age. Now go to settings. In the settings, click on Customize Test. Okay. In the Customize Test, click on Compare Median to a Hypothetical Median. In the Customize Test, click on Compare Median to a Hypothesized Median. Now here, as I said, we can apply sign test, we can apply Wilcoxon sign rank test. बहुत सारे टेस्ट होते हैं. Here इस वाले ऑप्शन में SPSS आपको वन सैंपल के केस में दे रहा है विल्कॉक्सन साइन रैंक टेस्ट. तो हम ये लगा सकते हैं, हम कोई भी टेस्ट लगा सकते हैं, राइट? So we will be going in for Wilcoxon signed rank test. Now in case of hypothesized median, what will we write? 25. Because this is the hypothetical value which you have to test. This value is a value of your choice. Just make sure you are clicking on compare median to hypothesized median. And it is applying Wilcoxon signed rank test. Click on run. As soon as you click on run, in the output window, you will see, yes, now this is your result of one sample Wilcoxon signed rank test. कुछ भी लगाएं आप, साइन टेस्ट लगाएं, साइन रैंक टेस्ट लगाएं, ऑलमोस्ट एक ही जैसा रिजल्ट आना है. नाउ दिस इज ये थोड़ा सा एक स्टेप आगे है. Along with the SIG p value, it is also showing you the decision, that is retain the null hypothesis. Why it is saying retain the null hypothesis? Because the p value is greater than 0.05. As I said, if it is greater than 0.05, you will accept the null hypothesis, yani retain the null hypothesis. And what will we conclude? We will conclude that the median age is equal to 25. The median age of the population from which the sample has been drawn is equal to 25. So this is how we apply one sample Wilcoxon signed rank test using SPSS. Okay. Coming to the next test. Now, suppose in this data, I have to see that whether the average age for male is equal to average age of female. Here we have gender variable, है ना? Age के बाजू में अगर आप देखो तो we have a gender variable. Suppose if I have to test that whether the average age of male is equal to the average age of females, right? So here we can either apply independent t-test or we will apply non-parametric equivalent. Since we have checked for the normality of age and it came out to be non-normal, that is why we will be applying the non-parametric equivalent. Okay, so let us see how to do it on SPSS. Analyze non-parametric. Now one way is कि आप यहाँ से भी कर सकते हैं, but if you do it from here, then थोड़े ज़्यादा dialog box बन के आते हैं and at times it is difficult. So it is easier if you go in with legacy dialog option. One sample के केस में मजबूरी है ऊपर से करना, but for other tests you can do it using legacy dialog. So what is the path? I am repeating it once again. Analyze non-parametric, legacy dialogs, and you will go for 2 independent samples. Why will we go for 2 independent samples? Because we have male and we have female and we have to test that whether the average age for male is equal to the average age of female. So we will go for 2 independent samples. Click on that. Now this interface is very much like independent t-test. अगर आप लोगों को याद हो, आप लोगों ने कल independent t-test किया था. This interface is very much like independent t-test. So in the test variable, what are we going to put? In the test variable, we will put age. In the test variable, we will put age. And in the grouping variable, we will put gender. Why gender? Because we have to check that whether the average age for male is equal to the average age for females. So in the grouping variable, we would put gender. In the define groups, now this is important. अगर t-test किया होगा तो थोड़ा ध्यान होगा. Now here there are 2 question marks which are coming. So it is important for you to define the groups. How do we define the group? How is male coded and how is female coded? So male is coded as 1. So 1 will be group 1 and female is coded as 2. So group 2 will be 2. जिस भी तरीके से आपने कोड किया है, you can put those codes here. In my data set, male is coded as 1 and female is coded as 2. So in whatsoever form you have coded, you can put it here. So group 1 is 1 and group 2 is 2. Then click on continue. By default, it has selected Mann-Whitney U-test. तो आपको याद रखने की भी जरूरत नहीं है. If you go for 2 independent on SPSS, automatically this dialog box would open. It is good if you remember, but even if you don't remember, you can see here that you can apply Mann-Whitney U-test. So by default, it has selected Mann-Whitney U-test. Now in the options, please click on descriptives because it is important. Like whenever we do any analysis, it is important that we the first table that you see is always the descriptive statistics table, right? So please click on descriptive, click on continue and click on OK. So this is the result of Mann-Whitney U-test. This is the test statistic. This is the descriptive statistics. This is the test statistic. And this is the p-value. Okay. Now it gives you asymptotic significance and it gives you exact significance. Always remember, if the software is giving you exact significance, please go for exact significance. Okay. Halaki, you can go with either of the two. Both the p-values are correct. It is not wrong if you go for any of the two. But if it is giving you exact significance, it is advisable that you go for exact significance. So the p-value, it is coming to be 0.443, greater than 0.05, accept the null hypothesis. And what do we conclude? That there is no significant difference in the median age for male and female. The null hypothesis here is that there is no significant difference in the median age for male and female. Since the p-value is greater than 0.05, so at 5% level of significance, we accept the null hypothesis. या फिर accept से better word होता है do not reject. So we do not reject the null hypothesis and we conclude that there is no significant difference in the average age for males and females. All right, I hope this is clear. Suppose if this hypothesis would have been rejected. मैं ये बस एक example बता रही हूँ आपको. Suppose if this hypothesis would have been rejected, then what we would do? We would say that there is a significant difference in the average age of male and female. If the difference comes out to be significant, then we see the mean rank. Whose mean rank is higher? जिसका mean rank higher होता है, हम ये कहते हैं that the average age for that particular group is higher. So suppose इस case में, in this scenario, suppose if the p-value would have been less than 0.05, we would have rejected the null hypothesis and we would have concluded that there is a significant difference in the average age. Then we would have said that females have higher age as compared to higher median age as compared to male. So this is just for you all to note that suppose your hypothesis gets rejected, please go up and see the mean rank. Clear? So this is the Mann-Whitney U-test. The next test is, so before I do the paired one, let me show you how to do Kruskal-Wallis, that is non-parametric equivalent of one-way ANOVA. Okay, now when do we apply ANOVA? As I said, since it is a generalization of t-test, so when you have to compare the average across more than two groups. So in this data, which is the variable which has more than two groups? FMI. Family's monthly income. It has three groups: low, middle and high. तीन group है यहाँ पे, low, middle and high. So suppose if I have to test that whether the average age for low, middle and high is the same. Then क्योंकि तीन group है, so we cannot apply t-test. So we will have to go in for ANOVA. Since age is not normally distributed, hence we will go in for the non-parametric equivalent, that is Kruskal-Wallis. So how to apply that? Analyze non-parametric legacy dialogues and you go to K independent sample. K means more than 2. Again, I'm repeating, it's analyze non-parametric legacy dialogues and K independent samples. Click here. In the test variable, put age. In the grouping variable, we will put FMI. Again, we have to define the range here. Now, low is coded as 1, middle is coded as 2, and high is coded as 3. So, what would be the range? Minimum would be 1 and maximum would be 3. This is very similar to अभी जो हमने मान Whitney U test किया. वहां पर we have to define the groups. Here we have to define the range. Why range? Because there would be more than 2 groups. Click on continue. By default, it has selected Kruskal-Wallis edge test, which is a non-parametric equivalent of one-way ANOVA. In the options, click on descriptive. Then click on continue and click on OK. Now this is your result of Kruskal-Wallis test. If we see the last table, this is your SIG value, again the p value. Since it is greater than 0.05, we accept the null hypothesis and we conclude that there is no significant difference in the average age for all the 3 family monthly income group. Since p value is greater than 0.05, you accept the null hypothesis and you conclude that there is no significant difference in the average age for all the 3 FMI. Here also we are accepting the null hypothesis. अगर ये p value less than 0.05 होती and if we would have rejected it, then again we would have made the hierarchy using the mean ranks. Okay, I hope Kruskal-Wallis is also clear to all of you. Don't worry, we will be taking the questions at the end. The last one is non-parametric equivalent of paired t-test, which is called, I mean, I'm not able to ask because you all are mute, but I will only answer, which is called Wilcoxon signed rank test. Now, in our data set, which is the paired variable, depress 1 and depress 2. This is the paired. Okay. So, first of all, we will check for the normality. It has to be normally distributed. So right now I am not checking it, but I am assuming that it is normally distributed. You have to check for normality of both the variables. If anyone is not normal, you will not go for paired t-test. Okay. Now suppose if my null hypothesis is that whether the average depression 1 score is equal to average depression 2 score. Right? How are you going to do it? Analyze non-parametric legacy dialogues and 2 related samples. So we have done 1 sample, we have done 2 independent sample, we have done k independent sample, and then we are doing 2 related samples. Suppose we have to see that whether the average depression 1 score is equal to the average depression 2 score. Click on 2 related. In variable 1, just put depress 1, and in variable 2, put depress 2. By default, it has selected Wilcoxon signed rank test. Now here you can check for McNemar also. I will not be doing it, but just for your information, McNemar is applied when you have a paired data, but it is dichotomous in nature. Somebody asked that, can you give an example? Suppose if, like I say that whether an individual has a disease at the time of, like when they came for first checkup. Okay, suppose individual had disease or not. तो 1-0 करके हमने कोड कर दिया, तो डाइकोटोमस हुआ. Okay, then after 1 month of follow-up, again whether we assess that whether individual still has disease or not. So after 1 month, again if we take the observation on same set of individuals, again we will have the data as 1 or 0. So again it is dichotomous, but the individuals are related. Related means same set of individuals पर आपने 1 महीना पहले लिया था और same set of individuals पर आपने 1 महीना बाद लिया. So you have a paired or a related sample, and you have the observations today and you have observations after 1 month. So it's dichotomous and it's paired. If it is dichotomous, which means it is coded as like 2 categories only, then you go for McNemar. तो इस केस में डिप्रेशन के तो स्कोर्स है ना, आप लोग देख सकते हो, you can see it on the screen. Depress 1, depress 2, they are continuous variables, they are scores. So here there is no point of applying McNemar. But suppose if you have a dichotomous data and you have it before and after, then you can go for McNemar. यहीं पर you can click McNemar. Okay. So here we are applying Wilcoxon signed rank test. So click on Wilcoxon. Then click on options. In the options, click on descriptive, continue, and click on OK. So this is the p-value, asymptotic significance. Here the p-value comes out to be significance for a change, which is a good thing. It is less than 0.05. We reject the null hypothesis and we conclude that there is a significant difference in the median depression scores. The p-value is less than 0.05. We reject the null hypothesis and we conclude that there is a significant difference in the depression scores before and after. Now, after we conclude that there is a significant difference, we have to see which is higher and which is lower. ये कैसे decide करेंगे? See the mean ranks for negative and positive. As you can see, the mean rank for negative rank is higher. The mean rank for negative rank is 14.3. Now, what does negative rank means? If you see this A here means depress 2 is less than depress 1. So here we can conclude that the median for depress 2, the median score for depression 2 is less as compared to the median score for depress 1. क्योंकि अगर difference है, if there is a significant difference, then you have to see that whether the difference is significant or not, number one, and then you have to find out which is higher and which is lower. As I already said, so if you have to see which is higher and which is lower, go to this value, whichever value, negative or positive, whichever has a larger value. So here negative rank has a higher value. See this, it is written depressed 2 is less than depressed 1, which means that इसको हम दूसरे तरीके से ये भी कह सकते हैं that the average depression score has gone down. It may be because of the intervention that was given, it may be because of anything, but we can conclude that the average depression score has gone down. Okay, I hope this is clear. Now, one more non-parametric, and then we very quickly go to chi-square, so that at least we are able to cover the tests and you all can practice later on. The last test, which is Friedman ANOVA, which is used as repeated measures ANOVA also, which is called K-related or Friedman ANOVA. Okay, when it is applied in the same data which is being shown to all of you, suppose if we have to compare average depression, like for day 1 and 2 अगर हमें करना था, so we have done it using Wilcoxon sign rank test. Suppose if we have depression at day 1, depression at second visit, and depression at third visit. So this is a case where we either apply repeated ANOVA, or if it is non-normally distributed, we go for the non-parametric equivalent, which is called Friedman ANOVA. So how to do it? Analyze non-parametric legacy dialogues and go to K-related samples. Here you can put all the 3 variables, depress 1, depress 2, depress 3. And by default, it has selected Friedman. So put depress 1, 2, 3 on the test variables. And by default, it has selected Friedman. In the statistics, click on descriptive. And then click on OK. Now this is Friedman ranks. And here p-value is less than 0.05, which means you will reject the null hypothesis and you will conclude that average depression score for all the 3 visits is not same. You will conclude that there is a significant difference in the average depression score for visit 1, 2, and 3. And very clearly we can see in the mean ranks also, and we can see in the mean also. Depress 1 का mean highest है, then depress 2, then depress 3. मतलब हम clearly कह सकते हैं that suppose if there was some intervention which was being given, we can very evidently say that that intervention has played a role in reducing the depression, because the difference is also coming out to be significant, and we can say that the average depression has reduced. We can say that whatever intervention has been given has played a significant role in reducing the depression. So we can conclude that there is a significant difference in the average depression score. Now the last non-parametric test that we will be discussing is the chi-square test. Now, as I said, chi-square test is used if both the variables are categorical in nature. Suppose if I have to test that whether there is any association between, in this data only if I take an example, suppose there is any association between gender and FMI. Okay, Now both gender and FMI are categorical in nature. So suppose if I have to test that whether there is an association between gender and FMI. How are you going to do it? Analyze, descriptive statistics, and crosstab. I am repeating it once again. Analyze, descriptive statistics, and crosstab. In the row, put gender, and in the columns, put FMI. In the row, put gender, and in the column, put FMI. It is not necessary that you put a certain variable in the row and certain in the column. It is the results of chi-square would not be affected. So it is purely your choice how you want your tables to be displayed. Then in the statistics, click on chi-square. In the statistics section, click on chi-square. Click on continue. In the cells, in the percentages, click on row. Suppose if you want to see column percentage, आप उस पे भी click कर सकते हैं. Suppose if you want to see row, column both, आप उस पे भी click कर सकते हैं. Suppose if you want to see the total, आप उस पे भी click कर सकते हैं. So in the percentages, click on row. Then click on continue. So in the row, put gender. In the column, put FMI. In the cells, in the percentages, click on row. And then click on OK. Now this is the cross tabulation between gender and FMI. This is the table where it has displayed row percentages. It can also display column percentage. And then we have the chi-square statistic and we also have the p-value. Since this p-value is greater than 0.05, we accept the null hypothesis and we conclude that there is no significant association between gender and FMI. Always remember, the null hypothesis for chi-square is that there is no association. So since the p-value here for chi-square is greater than 0.05, you accept or you do not reject the null hypothesis and you conclude that there is no significant association between gender and FMI. Agar ye value, if this value would have been less than 0.05, then we would have rejected the null hypothesis and we would have concluded that there is a significant association between gender and FMI. So this is all from my side about the non-parametric tests. We are now opening for questions. I am trying to read the chats. I am not sure if, since there are so many chats here, I think I'll miss on the chats which are the latest. I think any questions or doubts that you all have, recently you can write it on the chats so that, okay, I can read the last one from Aditya, which says in chi-square, if FMI has 3 categories, can we still apply? Yes, yes, of course you can apply. For chi-square, it is not important that you only have two variables or two categories. You can have any categories. I hope the doubt is clear, Aditya.
Good evening, ma'am.
Yes, good evening, Dr. Bihari. Please go ahead.
My question. You say that asymptotic significant or exact significant. In this
Yes.
case, we choose exact significant. But
Yes.
maximum cases, asymptotic significant so that.
When asymptotic significance is given, you have no other option but to go for asymptotic. But if in case exact is given, please go for exact.
Okay. Thank you so much.
Hello.
Yes.
Ma'am, how do we check for goodness of fit test, ma'am?
For goodness of it, I just showed you that we have applied Kolmogorov, Smirnov, and we have also applied Shapiro-Wilks. That was goodness of fit for normality. Other than that, if you want to do it purely on SPSS, then here you can see this option in the non-parametric legacy dialogues. We have one sample KS. This is for goodness of fit. Then when we apply one sample using this option, here also we have various goodness of fit tests. So from here also you can apply the same.
Okay, ma'am. Okay, thank you.
Ma'am,
Yes.
why was the cross tabulation done? Could you please explain that? I didn't get that last part.
Why was? Could you please repeat?
The cross tabulation which you did, which is selected from there, that part.
Okay, so you want me to do it again?
Why was the cross tabulation done? I didn't get that.
The cross tabulation was only done like normally when we have two categorical variables and we check for their association. It is important that you like represent it in a form of a table. So just as we showed descriptive statistics, so this is just a tabular representation of two categorical variables.
And ma'am, could you just once more repeat the process, how you did the cross tabulation?
Sure. I'll do it.
Thank you.
Analyze descriptive statistics and cross tab. Chi-square is applied using cross tab only. So analyze descriptive statistics, cross tab. It's always done on two variables only. So any two variables you can put on row and column. I chose gender and FMI. You can choose any two categorical variables. Then in statistics, click on chi-square because I have to apply chi-square test of association. Then in cells, I have chosen row percentages. Any one percentage is chosen generally. I have chosen row percentage and then click on OK. So first is your cross tabulation and then we have chi-square with the SIG value. So the null hypothesis is there is no association. So here it is greater than 0.05. Hence we accept and conclude that there is no association.
Got it, ma'am. Thank you.
Hello, why did you select from non-parametric test from legacy dialog chi-square test?
Yes, you can do it from there also, but generally we do it from this option only because there are a lot of other options also available here. So it is advisable to go with this.
क्लास चल रही है बस खत्म होने वाली है.
I have one query.
Yes.
See, if you have to given a choice between application of the chi-square and the Mann-Whitney, what should we prefer?
So Mann-Whitney test is applied when both the variables are continuous in nature.
No, madam.
And they do not follow normal. But chi-square is applied when both the variables are categorical in nature.
No, if in Mann-Whitney test, suppose it is not, even in case of the categorical variable, suppose it's nominal variable, mild, moderate, severe pain, or some ordinal things are there, then also we apply the Mann-Whitney.
In case if you have ordinal data, it is definitely better to go for chi-square as compared to Mann-Whitney.
Thank you much. Thank you.
Yeah, it provides Actually, the objective of both the tests are slightly different. One is checking for the association or dependence, and the other is simply comparing the medians, that whether the median is the same for the two or not. So how can you compare the median if like it is mild, moderate, severe? Sometimes it is out of place when we talk about that. So it's definitely better you go in for chi-square.
Thank you. Thank you much.
Most
Ma'am,
welcome.
in
Ma'am.
Mann-Whitney, how do we
Huh?
interpret the data in Mann-Whitney? How do we interpret the output, the mean rank, which is larger, which is small?
The one that is higher mean rank, that will be having a higher, you will say that has a higher average as compared to the other one, simply by seeing the mean ranks.
Thank you.
Ma'am,
Ma'am,
in this
in
data which for chi-square which you had shown, in case we did get significant difference that is they were associated, how would we
Yes.
interpret the crosstab in that case?
So
Can you
suppose if
just
it
give an
comes out, yes, I've got your question. Very, very important question. Suppose here it comes out to be significant. Then we say that there is some association between gender and FMI. In that case, we generally see the percentages, and then we say ki matlab maybe for males, middle income has a higher percentage as compared to female. Like whatever comes out to be your percentages, then in that case, after saying that there is a significant difference, we try to interpret it using these percentages. किसमें higher है, किसमें lower है, or if there is some trend that is being shown here, that you can interpret using the percentages or the trends in the percentage.
Okay, thank you so much, ma'am.
Ma'am, in the Kruskal-Wallis test, we compare 3 different groups and we get whether it is significant or not. So how to identify in between which group it is significant? The next step.
The next step, yeah, again a very, very good question. Suppose if in Kruskal-Wallis it comes out to be significant, we can make the hierarchy using the mean rank. Okay. Even if you are not able to just by mean rank, if you see that it is not a complete analysis, then what we do is we apply, like suppose if you have 3 groups, jaisa is data mein we had applied Kruskal-Wallis for age, that whether the average age is the same for all the 3 FMI, right? Suppose if it rejects, like if your null hypothesis gets rejected, then you will be repeatedly applying Mann-Whitney U test for FMI low middle, then middle high, then low high. So 3 times you will have to apply Mann-Whitney in order to check the differences. In case
Between
of,
which group it is significant?
yes.
Okay.
In case of ANOVA, we generally go in for post hoc. I think if you would have studied ANOVA, to pata hoga that in
ma'am.
ANOVA we go in for post hoc. Here there
Okay.
is no separate procedure for post hoc, so we repeatedly apply Mann-Whitney.
Okay. Fine.
Ma'am,
Yes.
suppose that we have to find out the which family income group have higher depression index, depression score 1. So how can we find out?
Suppose if you have to find which family has a higher depression index, you can
Yes, ma'am.
simply say if the score is not coming equal, like if it is not coming significant, you can simply see the mean rank. Whichever has a higher mean rank, you can go in for that.
Okay. Thank you, ma'am.
Ma'am,
Yes.
by checking the chi-square data, we can analyze which it shows the association, right? So
Yes.
we can see that it is showing positive or negative association.
Actually, association is not positive or negative. It's not like correlation. Yes, but we can see the strength of association. When you see when you apply chi-square, there is this option which is available on the chi-square. Since time was less, so I didn't go into that option. I'll show it to you since you have asked. Analyze, descriptive, then cross tab, then go to statistics. Here you can click on any of these. Suppose if both the variables are ordinal, you can click on gamma. If both the variables are nominal, You can click on any of these. So suppose in my case, it was gender and FMI. Now gender is nominal, FMI is ordinal. So I can either click on nominal or I can click on ordinal. Suppose if I click here, if I click on contingency coefficient, anyone you can click, then click continue and then click OK. So this value tells you the strength of the association. If it is near to 1, you can say there is a strong association, very strong. But if it is near to 0, you can say that there is poor association. यहाँ तो वैसे भी वो significant भी नहीं आ रहा. So anyways, this doesn't matter. But if in case this would have come significant, then by seeing this value, you can see the strength of association.
Okay, ma'am. Thank you so much, ma'am.
Hello, ma'am.
Yes.
Yes, ma'am. If there are two groups, like with treatment and without treatment, and if we want to compare the medians of both, like in the the data is ordinal, like Likert scale, based on Likert scale, then which non-parametric test we can apply?
So with treatment and without treatment would be two independent groups, because
Yes,
the samples
ma'am.
would be independent.
Yes, ma'am.
Yeah, so then you will be applying the non-parametric equivalent of independent, that is Mann-Whitney test.
Man, okay, ma'am. Thank you.
Ma'am,
Thank you.
how do we apply Fisher exact test and when do we apply in SPSS?
Fisher's exact test is applied for chi. It is by default applied in case of chi-square when any of the cell has observed frequency less than 5.
Okay.
Excuse me, ma'am.
Yes. Please go ahead.
Yes. So suppose, ma'am, you have two, pre-test and post-test values. And
Yes.
if the number of responses, say in the post-test, everybody did not complete it. There were lesser people, few less. So how do we go ahead?
Your sample would reduce. Your sample size would reduce.
Okay. And
there is no other option because the number has to be exactly same. सॉफ्टवेयर पे भी अगर आप डालोगे तो वो उतनों का हटा के बाकियों के लिए एनालिसिस करेगा, मतलब उतनों पर ही एनालिसिस करेगा जिनके लिए दोनों अवेलेबल होंगे.
But ma'am, if you're not able to match, in the sense you have separate things for the pre-test and post-test, and we don't know which one is for which person, can we go ahead?
No, you should not. It has to be paired sample only. If you put it on the software, it will give you the result. But in case of paired, you should always be sure that it is for the same individual only.
Okay. Thank you.
Okay.
Hello, ma'am.
Ma'am.
Yes.
Is size of test is depend on the sample size, either it is small sample or the large sample?
Yes, it does, but not always on the sample size.
Okay. So t-test can be used for the 100 sample size.
No. What happens is t-test is a small sample test.
Yeah.
So if you apply it for 100, it will automatically be normalized as z-test. But yes, people do apply t-test for 100 observations also. It's not wrong.
Okay. So it is automatically z-test.
Yes, it becomes large sample.
Yeah. Okay. Thank you. And paired t-test also, no? If it is
Yes,
normal data.
Yes.
Okay. Thank you so much.
Thank you.
Ma'am, you said about the Fisher exact test that observed frequency is less than 5, then we
What's the
apply
difference
this
between expected
Fisher exact test.
Hmm.
Ma'am, observed frequency means in each of the cell or the number of participants?
No, in each of the cell, if the
Yes.
count is in any of the cell, like there are many cells, right? So if
Yes.
it is less than 5, then you actually for a 2 by 2 table, Fisher's exact test is for a 2 by 2 contingency table. Fisher's exact test is calculated, and if it is not 2 by 2, मतलब अगर R cross C है, then automatically it calculates continuity correction. ये दोनों options SPSS पे available होते हैं. So for 2 by 2, we go in for Fisher's exact. If the count is, if the expected count is less than 5, and otherwise you go for continuity correction.
Okay. Thank you.
Ma'am,
Yes.
so what is the table value, critical value, and would it be useful for us to interpret?
I am not able to hear you properly, Dr. Ganesh.
I'd like to know about the critical value and table value, ma'am. In
Yeah. So what happens is that generally nowadays in the software it gives you p-value.
Yes,
This p-value is actually calculated from the tabulated value only. But in place of the tabulated value now, it gives you the p-value. So suppose if you have a value which is called the critical value, which is your calculated value. If you have that calculated value of the statistic, you can compare it with the table, like with the tabulated value. Suppose if you don't have that calculated value, so in order to ease it nowadays, the probability value or the p-value is given. In simple language, p-value is nothing but it is that probability value which is in support of your null hypothesis. Higher the p-value, more supportive it is of your null hypothesis. जितनी बड़ी होती जाएगी, obviously its probability, so it will lie between 0 and 1. But higher the p-value, more it is in support of your null hypothesis. Lesser the p-value, it is not in support of your null hypothesis. But we have to decide a cutoff. So that cutoff at 5% is decided at 0.05. 1% it is decided as 0.01.
thank you, ma'am.
Good evening, ma'am.
So I think now we have to close the session because
can I just ask one question? I'm sorry. Can I just ask one question? If it's
please,
sorry.
because
Thank
we
you
are
so
running
much,
late.
ma'am, for this. Yeah, thank you so much for this wonderful presentation. Ma'am, I just want to continue with a question that was asked regarding paired sample test. So if in the pre-test we have about 50 responses and in the post-test we have only about 45, then we cannot use the paired sample t-test, correct, ma'am?
You can use the
So
paired
in
sample,
that
but it will only be for those 45 responses which are
45,
common in
okay. Okay, but suppose we don't know the identity of those and we cannot match. Is it okay just to work with the means and then do a significance of difference between means?
No, but then you will have to be needing the observations, right? You
Okay.
can take the mean and calculate the value manually if
Yes.
suppose you don't have
So if I
any
find the mean of the post-test for 50 and the mean of the pre-test for 50 and then compare those means just to say whether there's some difference, would that be
but
okay?
then that would not be like, you should not call it as a statistical test. It would just be an exploration on the basis of means.
Okay.
You should not call it as a test then.
If I'm using something like a significance of difference between means, would that be okay?
It would be okay, but how will you be able to calculate the standard deviations and all? You would be needing the paired values, right?
Yeah, but if I cannot pair at all, but I've taken it as a pre and a post.
So that is
50
just
and
an
40.
exploration. That is just an
Okay.
exploration. You should not call it as a significance testing.
Okay, okay. Okay, I get that. Okay, thank you so much.
You're welcome. So if there are no more questions, thank you so much, participants.
Thank you so much, Dr. Shambhavi, for a wonderful and very informative session. So I am sure that participants have loved it. So I think if you will continue, so more and more queries will come up. So thank you so much. And if the further queries are there, Dr. Shambhavi is with us in the another session. So thank you once again. Thanks to all the participants for patiently and active participation. Thank you, Dr. Shambhavi. We'll see you again. Thank you
so much.
Thank you all.
Thank you, sir. Thank you.
And thank you to all the
Thank
participants.
you.
Thank you so much, ma'am. Thank you.
Thank you. And please share the data set if possible.
Yes, I will do that.
Please share the PPT if possible.
Yes. Thank you. Thank you all.
Thank you so much, sir. Dharmendra sir.
Thank you,
Thank
sir.
you.
Thank you.